Do you need someone to explain black holes to you? Well, this very intellectual, super cool man has got you. Oh yeah! Now, the first step is to actually understand what's happening. The sun is at a constant battle between its own gravity attempting to crush it and the nuclear fusion inside of the sun attempting to push outward. This creates a delicate balance between the two forces, and as long as these forces stay even, the star will remain somewhat stable. Take that, liberals. Now you might be wondering, what the flip is nuclear fusion? Well, it's when two atoms come together to create another atom, like hydrogen to helium. This nuclear fusion creates a huge amount of energy in the form of radiation that pushes against the sun's own gravitational force, creating the delicate balance. This is due to the atom becoming more stable and the potential energy going down. And the energy has to go somewhere due to the conservation of energy and is released as neutrons, energy, etc. For stars much larger than the sun, they have enough energy at the end of their life to fuse heavier elements like neon, oxygen, and silicon, and more. Every time a star fuses the next element, it has less time until it goes on to the next, due to less and less energy being produced the closer you get to iron. Once you reach iron, the most stable element, when the elements fuse into iron, there is no energy produced, and the iron builds up at the core of the sun until the balance between nuclear fusion and gravity is shifted into gravity's favor. Once the balance is shifted, in a matter of seconds, the star's core collapses. Once this happens, the sun rapidly implodes at roughly a quarter of the speed of light. All this mass goes straight to the core and is how heavier elements than iron are created. After this, two possibilities happens for the star. Either it turns into a neutron star, or a black hole if it had enough mass. Time for some facts. Oh yeah. Now, when you're actually looking at a black hole, you don't actually see what's inside of it. You see what is called the event horizon, which is the point of no return where nothing can escape unless it's faster than the speed of light. Now, if you're a nerd like little Timmy over here, you might be wondering, what does the inside of a black hole look like? My answer is, I don't know, man. Since nothing comes out of a black hole, or does it? The singularity could be really juicy, infinitely dense like Adam Friedman, at one point where we don't know. Our third and final fact here is that black holes actually spin really fast. This is due to angular momentum conservation. This is due to when a star becomes a black hole, it gets really compressed and much smaller than it was before. And in order for it to be the same amount of spin, you have to conserve that. And since it's smaller, it has to spin faster to make up for the less bigness, like Adam Friedman. According to my sources, some black holes spin up to 90% of the speed of light, almost as fast as me. Now I will attempt to explain Hawking radiation. Mr. Schmidt, if I get this wrong, please do not take points off. That would be really poopy. Hawking radiation is the theory that over time black holes lose mass/energy through a small amount of heat, barely above like 0 Kelvin, or absolute zero. This occurs due to space not actually being an empty vacuum. It's actually full of particles constantly popping in and out of existence. This is quantum theory. Combined with Albert Einstein's of relativity, they can't really coexist yet. We haven't figured that out yet. The main idea is that if these particles, one positive and one negative, spawn next to a black hole, the negative particle will go into the black hole while the positive particle will be ejected. And due to space and time being flipped in a black hole, making it possible for negative matter to exist inside of a black hole. Unlike normal space-time, which only positive particles can exist. The bigger the black hole is, the slower this process will be, and the smaller the black hole is, the faster this process will be. Something you gotta understand is that this is theoretical and won't happen for like a while, because there's plenty of stuff the black holes can eat before they get hungry, start evaporating. I bet Adam F's hungry right now. Anyways, yeah, this takes a while. Thank you for watching. Now, if you could please give me an A+, that would be scrumptious.